Hi, I'm Justin Garrison, and I'm a senior developer advocate at AWS. And today I get the privilege of talking to you about saving money with containers. So we've all heard about this container thing. Some of us are running production in it. Some of us are exploring it and just kind of investigating. And really, a lot of the times, big change in architecture comes down to new capabilities, what we can do that's different, new scale, new flexibility, all sorts of things that are really important. And one of those things also happens to be cost. So I want to tell you about what you can do to optimize your cost with containerized applications in AWS. So we'll jump right in and really just talk about the first piece of how do you save money? This isn't different with containers than it is with any other infrastructure. It's the same with any resource you're using. Is the way you save money is you spend less money. That's it. That's the entire thing. If we can figure out how to spend less money, then obviously we save some money. So what does that actually mean? There's a couple steps here in between on how you actually get to that, but basically spending less money comes down to, at some point, more money to do something else, profits, to investigate R&D, to reach a higher scale, to do things that you couldn't do before, because at some point there is a credit card or some sort of business effort that cannot be done if you spend all your money on, say, paper or toothpicks or something else, that whatever it is you're spending your money on. We can also look at how do we reduce that spend inside of infrastructure with containers. And the best way that I know how to do this sort of talk is by just telling a story, giving some real world examples, and putting everyone else in kind of the shoes of someone that needs to save some money. So let's look at that. I created a character here. This is a new engineer. We'll call them Sam. Sam is an engineer at a new company. Sam's really excited about taking on their first project and loves containers, lots of experience at AWS, really wants to understand just how the business works and how they can be effective inside this new workplace environment. Sam's manager gives him the very first thing after a couple of weeks of just getting familiar with the environment and saying, hey, Sam, we need you to save some money for us in our containerized applications. Sam's like, great, I'm an engineer. I can do this. I know how to take pretty standard engineering practices and apply them to any environment, whether that's developing new applications, trying new architecture, or even saving money. So Sam kind of looks at the environment and gets to this point where there's a lot going on. These environments grow organically over time. It's nothing new. That's sometimes the environment will be one little section of someone that spun up something and grow into two or three teams that start using the same or their own environments or have unique use cases for whatever it is they're doing. It's the same case with containers as it was with physical servers and VMs and whatever else you're using. This environment of continuous improvement and deployment is always growing, is always changing. It's never a static thing. Once it becomes static, it's really easy to say, well, I'm just going to cut off, these three things and save money there. But in dynamic environments, it doesn't really work that way anymore. Code changes, you have new users, new use cases, new features. All these things add up to new ways you have to explore the environment and figure out exactly where you can save money. So Sam looks at this environment and says, okay, well, I see a couple of use cases here. I see where I think most of the applications run, whether that's in EKS or ECS, whatever the case may be. Containers and what developers like doing is deploying to containers, so those are the environments they spun up. So Sam says, okay, I'm going to take tried and true engineering practices to understand how to save some money here. It basically boils down to this. Sam looks at the environment, evaluates what's there. It's exactly what they were doing when looking at the environments to begin with. Sam will adapt what they found to be something that's suitable for their needs, whatever that is. If it's they need new scale or new regions or whatever the case may be, Sam can take that learning and apply it to their specific needs. And then actually the third piece is act on that and figure out from the evaluation and the adapting of information into some actual actionable change. And that can be a variety of things. That can be adding new resources, new compute, new services, or taking some away and retiring things and rolling those features into existing services that maybe don't do the functionality now but could in the future. So let's look at this first step. Sam's gonna already kind of gets a handle on what the environments look like, but really needs to understand what does it look like inside of AWS? What do I need? Same thing for anything you're measuring, whether that's containers or compute or whatever it is, you need to have a baseline. You can't make changes without knowing what the current spend is or what the current cost is and where that money's going. So very first thing Sam decides is, okay, we need to figure out where the money's going right now. Sometimes that's already apparent, other times it may not be, and in a lot of cases that changes over time. You can determine this by looking at your bill, but in AWS we have a lot of other ways that you can more fine-tune and discover where the money's being spent, and that's typically through resource tags. So Sam understands, okay, tags are kind of the way to go. There's a lot of best practices documentation on how to tag your infrastructure and your applications for understanding the cost and where that's going. So cost structures and teams and how you want the applications to break down, it all really depends on your environment. But let's say you have a team that is your front end team and you want to understand, okay, how much money are they spending versus another team that is tools and services or back end. You can tag things based on their cost centers or whatever team strategies you have, and then relate that back to the bill. So Sam thinks, okay, tags is definitely the way to go. But there's a couple other things we might want to turn on inside this environment. Cost Explorer is a great way to deep dive into more current infrastructure needs. Instead of waiting for a monthly bill, you can use these tags and actually do queries based on whatever it is you're looking for inside the environment. So once you understand what the tags are and how they break down, you can use Cost Explorer to get a more up-to-date look at where spend is, because it turns out that spend changes a lot over a month depending on when your users come and use the services. If it's Black Friday in the US and there's a big sales event, beginning in November, you may not have as many customers as you will the day after Thanksgiving. So it's just important to understand how you can look up this information dynamically during the month based on these tags. And the third piece here is we're going to enable usage reports. Sam really likes looking at the Cost Explorer, but Sam also has other things to do during the day. So these usage reports can come out once a month after the bill and really kind of break down some of the information of where the tags, which tags were costing which money and which line items on the bill. So this is a great start. Sam says, okay, I think this is what we need to do. So next step here, Sam needs to actually evaluate and adapt those situations for their environment. It's pretty straightforward, again, with some best practices, understanding what your org chart is or how your applications break down. Sam can look at that and work with some teams or at least with cost management or upper management and say, okay, we're going to standardize on these 3 tags or these 4 tags based on, say, environment is prod, team is front end, and application is load balance or whatever it is. Sam can take those and say, okay, here's a table now that we can enforce inside of AWS to say all services and all containers and clusters need to have these sets of tags on them. And if they don't, you can actually enforce that, whether that's by policy in your environment, by just, people saying you're not allowed to do that. CI/CD systems can apply that, or even IAM permissions to actually block not allowing services to run based on whatever it is that you wanted in your environment. Great. Sam has this plan now, worked with management, has these sets of tags, is planning on enabling Cost Explorer and usage reports, knows who they're going to email with those reports and who's going to look at them, because sending emails isn't helpful if no one reads them. So it's a lot of work here that you have to say, okay, if we want to save money or reduce spend, we need to, again, understand what the baseline is, where we're spending, and how that money is being used for good of the business. So Sam now is going to act on that, roll out these changes. In some cases, that means recreating some resources. It might just be updating existing resources, whether those are Kubernetes clusters or load balancers or EBS volumes, whatever it is that Sam wants to do and how they decided that these tags should be applied. Now is time to actually act and put that into place. It's going to take a little while. Any change management probably takes some process inside of a company. But luckily, all of this information is metadata based on AWS resources, and in most cases may not need a redeploy. Some applications might, but for a lot of the lower level things, you can update it in place or pull that into, say, CloudFormation or Terraform templates, and updating tags doesn't necessarily require a complete recreate of the object. So great. Sam now tags those workloads, tags those environments, and that's all being rolled out. Cost Explorer is enabled, and once they get the information starting to flow in, Sam or any engineer or upper management that has access can really dig into it and get a more real-time look at where cost is, what they're spending their money on for applications and infrastructure. And then setting up those usage reports, again, making sure someone reads them. If you set up a filter and black hole them into the trash, or just mark them as red and don't ever look at them, it's not going to do you any good. So Sam is really adamant about getting someone that's regularly can check this stuff out and understands, besides just the finance department, because finance can see the bill, they know how much money's there, but they don't always know what the business value is or where the spend is going. So these are all important things to consider inside of your environment, to just know that someone is looking at it regularly. Made all those changes, we acted on it. We're back to evaluate. It's just this continuous loop, right? This is how engineers do anything. This is a great way to understand the environment and constantly reevaluate what's going on, because again, this isn't a static environment. These applications change, users change. So we need to constantly get back to this step and say, okay, what's next? What's next for Sam in their environment is really digging into those usage reports and finding the largest spend, because we can optimize dozens of things, but if the spend is always 1% or 0.5%, it doesn't really matter that you changed all these things when there's this larger piece that's maybe 30% that you could cut out. And that's really the important piece of these usage reports, is finding the largest spend and saying, okay, now we need to dig into this. We need to figure out, how do we make this large spend into something that is more reasonable, whatever the case is. So Sam, again, takes that usage report, figures out, okay, you know what, it might be compute that's 30% of the bill, or it might be storage, or it might be network traffic. There's lots of situations that it's up to you, it's up to your environment, your applications. In Sam's case, let's first look at compute. Sam says, hey, we have a lot of EC2 instances that are running. Maybe we don't need that many. Based on the containers, they all say they need, 8 gigs of memory and 3 CPUs. But when you actually look at usage, maybe they're only using a gig of memory and half a CPU. And so Sam can look at that and say, hey, we need to understand our workloads better. We need to understand it's not just someone picked an arbitrary number and never measured it again. You need ongoing measurements for these metrics, just like cost baselines. You need application metric baselines. And so Sam can say, okay, well, let's maybe look at some of these applications that are either larger applications by the amount of containers that are running, or the larger applications based on resource requirements, if they're not, or even disparity between how much they request versus how much they're using. Sam can look at all these things and say, okay, here's the biggest areas that will have impact, because one piece of our infrastructure might actually use up 50% of all compute, but it doesn't need it. And so Sam looks at that and says, okay, let's work with those teams, because it's probably not all one team. You're going to have to do some cross-team collaboration here and say, okay, I need to actually figure out with them what their cycles are, what their backlog looks like, and say, hey, if we change this number from 8 gigs of memory to 1, you might save the company thousands of dollars a month. And that's a great easy easy win to say, hey, this is a small, a small impact. We can deploy it in dev environments first, and then figure out from there what the actual cost is after we've used it for a month or a week or something. Second piece that Sam was looking at was all those environments that they had. Maybe they didn't need all of them. Maybe they have too many control planes, whether that's EKS or self-managed Kubernetes or something else that they're running that just takes up a lot of compute that is very useful for managing these environments. But maybe there's also use cases that they can consolidate some of these things. They don't need a new cluster for every application, but maybe reduce that by a couple different teams, or even application types. If you have a lot of applications that are machine learning jobs or web applications or something else, you can break those down into different types of clusters that use different types of compute in each cluster that's optimized for those workloads, which is really handy. And the larger the clusters, the more you can share some resources and bin pack things onto EC2 instances. Really handy to just be able to reduce some of that spend based on whatever the workloads are. There's also situations where you can have multiple auto-scaling groups or instance types in a single cluster. So it's not just about, this cluster is only for the memory-intensive jobs, or this one's for the GPU jobs. You can share your control planes and make it apply to multiple compute types. So all those things are things that Sam is looking at the environment and saying, hey, maybe these workloads can work together, and maybe these changes that someone made to their cluster don't need to be unique just for their cluster, and we can combine these other two applications into a single cluster, and everyone wins because we reduce some overhead for cluster versions and config changes, but we also can more tightly utilize the clusters themselves and what computes there based on those applications. Sam, again, found these things, adapted it in their environment, and now is going to act on that. Again, you're going to work across multiple teams here. It's unlikely that one team is controlling all of the spend in your container resources. So it's great if there's a top-down initiative that says these teams, this is a priority for either cost reduction, or there's a cross-team task force that is able to understand the complexities and backlogs of each team and say, hey, this isn't done in a vacuum. This is more of a DevOps model for cost spends, where the team that is responsible for reducing cost isn't only there to reduce cost, but also there to make the team successful and say, hey, your app's important, your backlog's important, but so is spending less money and being frugal sometimes with the money, and saying, hey, we don't just need to use 1,000 resources if we only need 100. And so understanding that cost breakdown and still working together with the app teams to make sure that they're moving at a pace that is comfortable for them and they're going to be successful is super critical in gaining trust on those teams. And Sam's all about being successful now. So Sam's putting in that action. Again, it's more change requests and change process to understand how teams are deploying their applications, maybe send some PRs, but really it's just about working with the people and making them comfortable with what the changes are going to be. Sam figured out from that reducing some of those control planes, we're able to migrate applications from one cluster to another, whether that was just based on a regular push by changing a endpoint, a target for which cluster it gets deployed to, or it was a matter of slowly doing A/B testing based on resources in the cluster. These are areas where there might be some application impacts, but in the end, being able to reduce some of the overhead of managing those clusters. One of the selling points here is you can tell those app teams that had their own cluster, hey, you don't need to manage that anymore. When a new version comes out, we'll do that for you. If there's a new security patch, we'll handle it for you. And these are all things that consolidating some of the control costs not only is a good impact or a good reduction for spend on your bill, but also just your people hours inside your environments. There's people that do probably build AMIs and roll them out to clusters and are very safe on how security patches get rolled out. And if you can reduce their overhead by allowing them not to do it to dozens of clusters, but to do it for a handful of clusters, that's a great reduction just in time spent, and applications will run smoother, and you'll probably have less outages with less complexity. While we're at it, Sam also looked at enabling Compute Optimizer, which is a great way at looking at those workloads and saying, hey, these machine learning jobs or these web services or whatever it is might be better used on a different type of compute instance, whether that's a C class for compute or an M class for memory, or even GPU classes. These are all different ways to understand just how much they're being used, but also if you look at how much memory and CPU resources each instance type has, Sam can really break that down into a way to understand how to best utilize them based on those compute optimizations we made earlier by saying, hey, this job maybe doesn't need that many resources. Let's minimize that and say, okay, now we can fit more jobs on fewer EC2 instances. That's a great win. And may even be looking at something like Fargate and saying, hey, we don't need instances at all because we can run these instances or run these applications in their own instance isolation based on Fargates, which further reduces that overhead complexity for managing instances. Sam also looked at the amount of resources that were there that maybe didn't need to be there anymore. Things like old EBS snapshots or S3 revisions or things that, load balancers that were for applications that don't exist anymore. A lot of times these things will creep up and grow, but they're not often the most critical or the most expensive thing inside the environments. It's good to clean them up. You can automate some of this. You can find scripts or build scripts that look for EBS volumes that aren't attached to things or load balancers that don't have target groups. There's lots of ways you can optimize this, and Sam in their environment took the top 3 things from what they found in the usage reports and tried to make some adjustments and tried to automate that to say, okay, maybe I don't want to shut them down immediately, but I do want a weekly or a monthly report based on what percentage of my S3 buckets have objects in them or EBS volumes have been mounted to something. These are all things that Sam's able to do based on those tags and based on some of the consolidation as well. By reducing some of that complexity of the environment, Sam was able to more clearly understand, okay, this load balancer goes to this application because of these tags or because of this cluster. So all useful things that Sam was able to do and kind of make an adjustment on. We're back here, top of the list. We made some changes. We need to evaluate it again. Again, these environments are not static. They change all the time. The applications change. The resources do need to be constantly reevaluated to say, okay, maybe I rewrote an application from one language to another, and this new language is better at memory utilization or garbage collection, or CPU is going up now. I need more cores or something. So those are all areas that engineers should know how to do. You should have baselines and constant metrics gathering to understand what that looks like, and then just a way to adapt that into your environment. So Sam's back. We evaluated all these things. We just made all these compute changes, made changes to clusters, consolidated a lot of things, and Sam's really going to dive deep into these workloads. That's kind of the next place that's the best optimization is usually going to come from, is based on either reducing some of the repeated work where someone is duplicating the same S3 bucket over and over again, or the same information in EBS volumes, or same database structures. And some of that can be collapsed into individual resources, or in some cases, just again, extending applications to allow them to combine and say, hey, this user's API had these 4 features, but the one over here had one feature that one didn't have. So maybe we consolidate that and reduce some complexity in our environment. And Sam's also going to look at, we got rid of all the load balancers that and S3 buckets that we didn't need anymore. But again, with this consolidation, things like the AWS load balancer controller for Kubernetes, you can share load balancer endpoints on multiple applications. So you don't need a load balance, an ALB or an NLB for every application. You can say, okay, well, this team or this environment shares the same load balancer to reduce some more spend. Again, It's not the big ticket items often. From whatever your environment looks like and from those usage reports, you can really figure out where the spend is going. But this is often understanding your workloads under a more fine grain, like a magnifying glass or whatever, and just knowing what resources they're consuming. Did you need that 100 gig EBS volume, or are you okay with 20 gigs? Do you even need an EBS volume, or can just use scratch space that is ephemeral? These are sort of things, the consolidations and just understanding your workloads more is really critical for kind of this bigger drop at the end of, hey, we reduced that first 30%. Now where's the last 10 or 20% of spend going? And again, like I said, this isn't a static environment. This is dynamic. We have to keep looking at those resource utilization for our compute instances and also for our applications, understanding through CloudWatch or whatever metrics you're gathering, say, hey, after this deployment, things changed, users changed, or the applications changed, or new features of Amazon, right? AWS is constantly rolling out new features that we want customers to take advantage of. We love it when customers actually spend less money on their existing infrastructure. The ARM instances, the Graviton 2 instances is a great example of that. We have a lot of, not a lot, I mean, there is a lot of customers that are reducing spend based on cost of moving to Graviton. And so that's actually this next step of adapting. Maybe Sam's environment, Graviton makes sense for their compute instances, and it has better performance characteristics than Intel, and it's cheaper to run month to month. So there's a lot of cases where, hey, this web service might just work, and we can rebuild it in a ARM architecture and run it on Graviton and get great performance boost out of a reduced amount of EC2 instances. So Sam's looking at those things too. What does it take to actually move architectures? What does it take for the builds system, the CI/CD, and also your registries? Docker and containers are great at multi-architecture compute. Registries already support that in manifests, and runtime support that when you execute it. In a lot of cases, it's kind of invisible. Once you have the right architecture application pushed up to a registry, your container runtime is just going to do the right thing, which is really quite amazing in a lot of cases. It wasn't always that way to be able to change full architectures for a host OS, but with things like Amazon Linux and containers, a lot of that just kind of becomes transparent. Even if Amazon Linux 2 on Graviton is going to be the same as it is on a standard Intel or x86 architecture. And the containers, as long as you built them, x86 and ARM, you can still run them on either. And so you can start by experimenting inside of container clusters, maybe put a auto-scaling group and a node group inside of your cluster and figure out what is the best use case for you and where some of that spend can be reduced just on those compute instances. And also with that, understanding how your application is healthy and when it needs to scale. In some cases, applications might actually work better if they're consuming more memory and more CPU. It's not always a sign that you need more of them. If you're doing machine learning or rendering, ideally you're actually using a lot of the compute and you don't need more instances. You just want to more efficiently use the resources that you have. And so enabling health checks will allow us to scale up and down more quickly, because a big way to waste money is to run instances and compute jobs that aren't serving traffic and are unhealthy. And if they're unhealthy and you don't know about it, until someone checks it out or you have automated health checks, it might just stay there running for who knows how long. So really digging into those applications, cross-team collaboration, and understanding how the application is being used, and if it doesn't have access to, say, a database or a DNS endpoint or a load balancer, should it still be running? That's up to you. Sam has to look at that for their own environments, and really it's up to your applications as well to know, do I need this? And that's great to really dig into it and understand your application for health checks and when to scale. Here we are, we understand those health checks. This ACT step is really just about enabling those auto scaling, whether that's based on requests to the endpoint, to the load balancer, whether that's based on CPU or memory, or even time of day. You can just automatically scale that up and down time of day. The weekends, if you have dev environments, you might want to spin those down on the weekends. These are all ways that you can save money automatically based on auto scaling, which is just a great way to do it, because you don't want people to be in the critical path to say, oh, we should turn these things off now. You should let the metrics and understanding your workloads do that for you automatically. Sam's back to this loop every day. Sam did a great job understanding where that cost optimizations are, how to save some of that money. And a lot of times it's really about finding the largest spend and reducing that. Reducing duplication, figuring out what compute is great for you, for your workloads, and really it comes down to understanding your workloads the best, and how to reduce that is really, end of the day, the engineering loop that matters for the applications, matters for the container infrastructure, but also for your spend. And that's really it. So thanks for coming to the talk. I hope you're nice and cozy at your house watching this, and I really, please rate the session. I really enjoy that. If you like this, if you learned something, please let us know, and have a great day.